Okay, so in this video we're going to be looking at the centroid and the orthocenter. So remember, to do the centroid, our little saying was milk and cookies. So the M really standing for the medians, and if you draw the medians of a triangle, that will give you the centroid. So how do you draw the medians of a triangle? You go from the midpoint of one side to the vertex that will be across from it. We're going to do that here in just a second. So you can use a ruler. In fact, you don't even have to have a protractor for this one, but I'm going to use my protractor just because I have it here with me. So this side here is just a little bit shy of 10 centimeters, so the midpoint will be a little bit shy of 5, about right in there. The length of this side here is about 7.5, so the midpoint will be at 3.75, 3 3/4. This side is also 7.5, so its midpoint will be 3.75 also. So we have our midpoints. Okay, so we're supposed to connect this midpoint to the vertex that is across from it. You want to do that with a straight edge. You want to be as accurate as you possibly can with this. And we're going to connect this midpoint to the vertex that's across from him. That's how you draw a median. Midpoint to vertex. And then lastly, we'll connect this midpoint to this vertex over here. Okay, so if we're as accurate as we possibly can be, where all of our medians are intersecting right here, this would be our centroid. Okay, now let's remember what his property is. Remember, the centroid has the whole 1/3 and 2/3 of the entire median is his property. So we'll talk about that here for a second. So if you could imagine taking this median and splitting it into thirds. Okay, so for instance, if I told you that the whole median was 6 units long and you split that up into thirds, that means you split it up into 3 equal pieces. So we would be saying this is obviously one piece here. You see how up here is significantly longer. That's because that's my 2/3. So if you imagine trying to split this up into 2 parts that are the same length as this part, now we have our 3 equal parts. So if our median was 6 all the way across, 1/3 of 6 is 2. Okay, so each of our congruent pieces is 2. So that would make sense that this top piece that's 2/3 is 2 plus 2, which is 4. So here's our 2/3 of the entire median. Here's our 1/3 of the entire median. And that would be true of these also. These don't have to be the same length, but they would also be 1/3 and then 2/3, or whatever they are. Okay, so that is our centroid. Now, on this one here, we're going to be looking at the orthocenter. Okay, remember our saying here, O stood for oranges. What goes with oranges? Apples. Okay, but in real life, we're talking about altitudes here. If you draw the altitudes of the triangle where those intersect, will give you the orthocenter. Okay, this is the hardest one to draw. The altitude of a triangle is basically going to take your vertex, and you want to go straight down, perpendicularly down to this bottom side, your base, basically. Okay, so what I like to do is it's kind of easy to see here because I can see my 90 degrees. I'm lining up with this bottom side down here. If it's hard to see where your 90 degree is, you may need to use a ruler on top of your protractor. You basically want to slide along this bottom side here, this base, until your 90 degree line is, you're lined up down here with your base, and our 90 degrees is going through that vertex. Okay, so I'm going to draw a little line there. And come over here, use that straight edge to just bring that on down. Okay, this would be an altitude. It's going from that vertex straight down so that it is perpendicular to our base. Now we have to do that with all of our sides. So I want to line up with this side, and I need to know where is the 90-degree line, the perpendicular line, going to go through that opposite vertex. So I put my ruler on the 90 degrees there, and I need to slide, making sure I'm staying lined up here, lined up on that side, and I want to slide along that side until my 90 degrees is hitting that opposite vertex there. So this is the hardest one to draw. I'm going to mark right there, 90 degrees is going through that vertex, lining up with that side there. Hardest one to draw for sure. On a test and on a quiz, I will never ask you to construct this one, but it's good to know. Okay, so we have to find the last perpendicular line that's going to hit through that vertex. So I'm going to line my protractor up on this opposite side here. Okay, I'm going to get it as close as I possibly can here, using a ruler or something to say, okay, there's my 90-degree mark. That was pretty good. All right, I'm lined up over there on that side over there. Make sure I'm straight over there. Okay, 90 degrees. It's pretty close. Okay, sorry, a lot going on here. Okay, so it's going to be slightly off. I mean, you got, human error here where it's hard to keep everything straight. It's pretty close though. All right, so where all these altitudes are crossing, that right there would be our orthocenter. Remember, orthocenter, hardest one to construct, and he doesn't have any special properties really to speak of, okay? So the only thing he's really got going for him is the fact that this is a perpendicular line. It is making a 90-degree angle going through that vertex there, okay? So we're going to dive into some of these and look at some more specific cases with these. Okay, so here we're using the property of the centroid. Remember, the property of the centroid is the 1/3 from the midpoint to the center will be 1/3 of the whole median. From the midpoint to the vertex will be 2/3 of your entire median length. Okay, so they tell me S to Q is 8. Okay, so looking at this picture here, SQ, you can imagine that seems to be the longer segment there. So I'm imagining splitting it up into thirds. I'm imagining splitting it up into 3 equal pieces. I see that that's my 2/3 piece. This down here would be my 1/3 piece. And you can kind of visualize our 3 congruent pieces. So if S to Q is 8, 8 divided by 2 means that each of these pieces had to have been 4. So this piece down here is also 4 because we're splitting into 3 congruent pieces. So when they want from Q to W, we see QW here is 4. When they say SW, here's S, here's W. So they want the length of the entire median, okay? So 4 plus 4 plus 4, or you can say 3 times 4, because we've got our 3 congruent pieces and each piece is 4. We understand that SW is 12, okay? So there's your 1/3, 2/3 property there. All right, a lot going on in this figure down here. There are 3 paths in our triangular park. Each path goes from the midpoint to the opposite corner. So we're going from midpoint to vertex, midpoint to vertex, midpoint to vertex, okay? So that is literally the definition of a median. They have basically told us, hey, we have drawn the medians here by how they explained how they've drawn these. All right, so they tell me from S to C is 2,100 feet, or 2,100 feet. S to C is right here. So that is an entire median there, okay? So I need to visualize splitting this up into my 3 congruent pieces. Be 1 piece there. Probably about right in there. Be my 2nd piece. And that would be my 3rd piece, okay? Splitting it into 3 congruent pieces. So if I take this, SC is 2,100 feet, and I want to divide that up into 3 equal pieces, then we would see that each piece is 700 feet. So 700, 700, 700. So they're concerned with P to S. P to S is just my 1/3 piece. So that'd be 700. Easy. P to C we see that that's our 2/3 piece. So we have 2 of these 700-foot pieces. We understand that that's 1,400 feet there. All right, now this one's a little bit tricky. They're talking about TC, BC. They tell me that from B to T is 1,000 feet. Look at your figure. B to T, this is not using our 1/3, 2/3 piece. This is using the fact that T is my midpoint. And if T is my midpoint, what's true about these two pieces here that I've highlighted in blue? Well, it should be that they're congruent, right? Because midpoint bisects it. So if BT is 1,000 feet, then TC is also 1,000. And when they say BC, they're talking about all the way across, okay? So BC would be 1,000 plus 1,000, or 2,000 feet, okay? All right, and then they tell me that PT is right here. They tell me that PT is 800 feet. So notice that it's different than the purple one, okay? But that's still part of a median. So I want to try to split this median up into 3 congruent pieces. Okay, so there's 1/3. Here's another third. And this would be my third, I guess you could say, okay? So PA, P to A, that's my 2/3 piece. So I have 2 of these 800-foot pieces, so P to A would be 1,600 feet. TA is all the way across that entire median. So I have 3 congruent pieces, each of those pieces being 800, so we understand that that entire median then is 2,400 feet. So understanding the different parts of the 1/3, 2/3 relationship in your centroid. Okay, now Orthocenter. We've already talked about the fact that he really doesn't have a special property, but there is something kind of special about just kind of how he's drawn. It tells me that Z to C is an altitude. So remember at the beginning of this video we talked about how you construct an altitude. It has to go through the vertex and it has to come down so that it is perpendicular to this base or this side of the triangle. Now they're talking about angle CYW, so from C to Y to W, so ultimately they're talking about this angle down here, which I'll mark there, and they're telling me that angle Y basically is 9x plus 38. And then they go on to tell me some information about angle WZC, from W to Z to C. WZC is talking about this top angle up here, which I'm going to mark with 2 congruence marks. And they tell me that that angle can be represented with the expression 17x. So what you have to visualize here, I'll kind of outline it first so that maybe it'll make more sense. You kind of have a triangle within this bigger triangle, okay? So we have this, which is our altitude, which I've highlighted in blue, and we know that he's 90 degrees there. They're talking about this angle, okay, which you can see we're looking at this triangle that I'm outlining in blue, okay? It is a fact because of linear pairs that if this side's 90 degrees, then this side does have to be 90 degrees because they are on a line, they have to make 180. Now, looking at this triangle, we know that this angle is 90 degrees. We have some information about this angle, and we have some information about this angle. What do we know about the angles inside of a triangle? They add up to equal 180 degrees. So we're going to take the 17x plus the 9x plus 38 expression, plus the fact that this guy is 90 degrees. You have to add up all 3 angles added together will equal 180 degrees. And we're going to solve this equation, okay? So if we combine like terms here, they give us 27x. Combine like terms here, we get 128. We'll subtract that 128 over. Bring down our 26x. This gives us 52. Divide. And we see that x equals 2. Not your final answer though, okay? Because they're asking us about the measure of angle WZC. WZC is talking about this top angle. Now that we know that x is 2, I'm going to substitute that in. Everywhere I see an x, I can plug in a 2. We multiply that out and see that this angle up here is 34 degrees. So even though the orthocenter does not necessarily have a special property, we are using the fact that the altitude is a 90-degree perpendicular line and then looking at this right triangle here and just using some properties of triangles that we've used in the past. Okay, so that's fair game for the orthocenter, even though he doesn't have a special property all to his own. Okay, so we're not going to worry about all this graphing over here. We're going to do that probably tomorrow in class. But let's look at some of these phrases here, okay? It says using fill in the blank with always, sometimes, or never. The centroid is always, sometimes, or never on the triangle. Think back to the other day when we used the computer program to look at the different cases of what happens in an equilateral triangle or a right triangle or an obtuse triangle. And hopefully you'll remember that the centroid was always inside the triangle no matter what type. He was always inside the triangle, so we would say that he is never on. On the triangle means like on the edge, on the side of the triangle. So centroid is always inside. Orthocenter. Orthocenter and circumcenter were sometimes outside of the triangle. And you remember that the sometimes when it did go outside was if it was an obtuse triangle, then it went outside, okay, for both of these. And then if it was a right triangle for both of these, it was on the edge of the triangle, okay? A median is always, sometimes, or never the same line as a perpendicular bisector. That actually is sometimes. Sometimes that can happen because a median goes from your midpoint to your vertex, and a perpendicular bisector is at your midpoint going 90 degrees through your midpoint. Sorry, my dog's barking in the background. So that could happen sometimes, okay, in some certain scenarios. An altitude is always, sometimes, or never the same line as an angle bisector. If we go back to our first diagram here and look at this altitude, it seems like it could be very close to bisecting this angle here, okay? Obviously this one's not, but you could see that this one's pretty close to bisecting that top angle there to where this side would be congruent to that side. So we're going to say sometimes there, and the sometimes case actually being that if it was an equilateral triangle, then you'll see that happening. Lastly, the centroid and orthocenter are always, sometimes, or never the same point. Okay, that is also a sometimes. Okay, and that is also going to be if you have an equilateral. If you have an equilateral triangle, that could happen. Okay. All right, lastly, the centroid is always, sometimes, or never formed by the intersection of the three medians. Remember our saying, okay, milk and cookies. Okay, so you always get the centroid by the intersection of the three medians. That's always going to happen. That's literally how we construct the centroid. So that's always going to happen. Okay, so make sure you have these notes written down, and we're going to revisit this and practice this a little bit tomorrow in class.